of the space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy, is known as the universe. 13.8 billion years ago, the Big Bang was the moment when the universe began as a tiny dense fireball that exploded. Everything that has a beginning has an end. Humans, animals, black holes, atoms. Even this video itself has a beginning and an end. So does the universe. The Big Bang was the beginning of the universe, and now it's headed towards its end. We can't tell the exact path it will go down on, but what we can tell is there are many possibilities, which means there are several ways. Some of them are rather patient and boring, while others are pretty much wild. So, we already discussed about the Big Rip and the Big Crunch, and now we know. Scientists estimated that the expansion speed is probably not great enough to rip us apart, and not low enough to crush us in the Big Rip or in the Big Crunch. That would ensure that the universe will live a very long and rather a peaceful life, but not that peaceful for our Milky Way, since we got Andromeda en route for collision in about 5 billion years to form Milkdromeda. But no worries. The chance of our solar system being disturbed by some rogue star is pretty slim. In that case, a reason to worry would be the Sun losing its shape and size and engulfing the Earth at the same time frame. But I think if humans find out a way to survive until then, we would manage to find a way to escape it. So let's get back to the topic. The most realistic end of our universe is known as the heat death, the big freeze, and also the big chungus. The future, 20 times more to 1 trillion years, and all the galaxies from the local supercluster will have merged into one final galaxy. All other galaxy clusters will have disappeared beyond the observable horizon due to the universe expansion. By then, any civilization born in that period will have no way of knowing of the existence of other galaxies or the Big Bang. For that matter, they would think their galaxy is the only one in the universe and would probably make some religion out of it. By the next trillions of years, stars will start decaying into white dwarfs, neutron stars, and black holes. By the end of the stellarous era, star formation will end, giving the start to the degenerate era, where only planets and degenerate remains of stars remain. In 1 quadrillion years, the planets will have decayed their orbits or will have flung into outer space because of close encounters with other remains. Add 5 more zeros to our time frame. 95% of the remains would have flung out of the galaxies into the space, while the rest falls into the central galactic black hole, which would create a very high quasar. What happens next depends on whether protons decay or not. Could they? The thing is, scientists doesn't yet know. Everything in the universe tends to lower their energy and become more stable. For particles, they just simply decay themselves into smaller particles. So there could be 2 different outcomes. For now, let's just assume that they do. In about 10 decillion years, all photons and neutrons that made up any matter in the universe will have decayed into photons and leptons, leaving only the black holes in the universe. This would start the black hole era that would last around a Google year, until all black holes will have slowly evaporated through Hawking radiation. This radiation will heat the black holes. During the last evaporation stages, black holes will be the last things to shine in the universe. With the death of the last black hole, the dark era would begin, with the universe barely containing some photons, electrons and neutrons. This is the end. But we can give a non-zero probability because maybe quantum fluctuations might trigger a new Big Bang in an estimated 10 to the power 10 to the power 10 to the power 56 years. Yes, it is a ridiculous number. Just you could know how ridiculous it is. If the time length between the Big Bang and now is 2 centimeters, the time length till a new Big Bang would be more than the observable universe. You know, it is better to have a slightest hope than the thought of eternal darkness. And now for the second outcome. What if photons do not decay? Photons are at its most stable state, as the standard model says. Scientists yet doesn't know it exactly. So, now let's look. What would happen to the heat then? How will it change according to this fact if photons do not decay? You know iron, the common thing found in Minecraft caves, that mysterious things that make clothes better in shape. Ferrous, also known as iron, could be the thing that make up the last stars in the universe. If it wouldn't take a long amount of time for the universe to cool down and die through the heat death, since the iron has the lowest energy level of all. Let's fast forward to the degenerate era, where there's nothing but black holes, fading stars, and rogue planets. In about a long time, all matter as we know will slowly decay into iron. This will happen by nuclear fission. The element with the largest half-life is tellurium, which will decay in 160 trillion times the age of the universe, which is 10 to the power 24 years. But this would be like a blink compared to the time it would take for the lighter elements for this ionization process. Only way that this could happen is through cold fusion. It's not like the thermonuclear fusion that happens inside the core of the star. It can happen under any temperature and any pressure. In low temperature, nuclei are so far apart from each other that almost nothing can make them pass through the electromagnetic force barrier. But it would happen through something like teleportation, and it's known as quantum tunneling. There is a very small yet non-zero probability that everything transforms to iron these days, and all the iron atoms would come together in clumps to make iron stars, and it would take around 10 to the power 3200 years. Take a universe full of atoms and replace every atom with a universe, and replace all atoms in those universe with a universe. Multiply this cycle with 40. and count an atom per year. That super mega universe counting time would still not be enough for the time that would take for this ionization. In the meantime, some black dwarfs will explode into supernovas in about 10 to the power 1000 years because of accumulating of iron. They will be the final fireworks of the universe. Iron stars will collapse into black holes in about 10 to the power 10 to the power 76 years. It's like writing a zero per atom in the universe in order to make up the time frame. Eventually, newly formed black holes will evaporate through Hawking radiation in about 10 to the power 108 years. What happens next is very speculative, as we don't know the role of dark energy. So don't worry, the universe has a long way ahead. For now, take care of the planet and hope that we can survive as much as the universe can. Thank you. Stay safe.